Thank you, Manoj, for your very kind words. It's always a pleasure to listen to you, and I couldn't resist your persuasive skills. And although with a lot of, you know, lot of reflection, I decided to speak on this particular topic. Thank you, Professor Rajivan, for this invite to speak in your clubhouse or your room or whatever this is called. I really like what you said because I think it really speaks to many of the discussions and debates many of us have had. And it also goes back primarily to the question of the relevance of philosophy in India today and how philosophy should be done, who should be doing philosophy, etc. So I'm sure that the same title, today's title, there are many who might want to say that you may want to save philosophy from philosophers, and similarly for other disciplines. And in many of them, they are probably just a reflection of the way institutions and academic practices intrude into disciplines. But anyway, that's a very different discussion, which perhaps we should have another time. As Dr. Rajivan said, there was, I think there's already been some kind of a trouble with this title of this talk, and it's something which I'm used to, so I'm not too worried about it. When I wanted to use that phrase, the title Saving Science from Scientists, there was a subtitle to it, which was the role of philosophy. So it is basically about more than saving science from scientists. It was actually to talk about what does a philosophical reflection mean, and more importantly, what does the idea of science actually mean. So I have heard a lot about your clubhouse, your room, this particular forum, and the discussions in the forum. And I know there are many scientists and students of science here. And I must also tell you that I choose a title like this only because there are so many of the science people here. Not because it's a point about scientists, but because I know that if they have the true spirit of science, they will be open to a critical examination of what science really is. So, with that hope and with that, optimism, I'm going to say what I'm going to say. I want to begin with a very simple observation that the title itself is a philosophical exercise, because it may seem to many people that I'm saying something by using the title Saving Science from Scientists, but actually, if we just reflect on that particular question, it's really not about individual scientists. We all know, I know personally, since I've been always been surrounded by science institutions, some of my best friends are scientists with whom we have very vibrant discussions on these same topics. And therefore, the word scientist here does not refer to all scientists. And this is references to, it's like somebody saying that, for example, the word Brahminical to refer to a whole class of people or forward caste, or if you want to refer to men in the context of feminism, you would refer to all men as a class without then, imagine everybody saying, no, I know this man who is not like that, I know that man who is not like that. But the point of the discourse of this particular kind of discourse is to recognize this class nature of the terms that we use. So, definitely, it is not about pointing fingers to any individual scientist, etc. And hopefully, people who read such sentences will learn to recognize how to read them properly. Secondly, the word which is also very ambiguous in this title is the word science. So, when I'm saying saving science from scientists, we could be saying a lot of things. And I want to go back and say, when you reflect on the sentence, it's actually asking us to reflect. It's not a declarative sentence. I'm saying it's actually asking us to reflect about the meanings of terms like science, scientists, and of course, as well as the term philosophy, but which is not very important in today's talk. So I'm talking about the term science and scientists. And what are the questions I would want to ask about it? I want to ask, what is science? What does actually the act of science do? What should be called science? And, are there identifying markers for the different sciences? There are thousands of subdisciplines which are grouped under science. There are hundreds of subdisciplines within each of the disciplines of physics, chemistry, biology, etc., which are grouped under sciences. And it is obviously a natural question for anybody, and particularly from the discipline of philosophy, whose task is to understand in the concepts and find conceptual clarification. It is their task to ask, well, what is it that makes all of these be put under a single family called science? And that's a very legitimate question. It is, if you want to extend this idea, and I'm going to use the word scientific repeatedly here. So let me say that this is a scientific question because it is the foundation of the early practices of science, and of course, even in contemporary practice. All you have to do is to go back and read Newton's magnum opus, the Principia, to actually look at the methods of doing science, what Newton calls as the philosophical methods, the four philosophical methods. So, the term science we need to understand, and if people think they know exactly what the word science really means and that they have full understanding of it, I would really like to listen to them, and I'm sure many scholars around the world would like to get a simple answer of it. And part of the study of understanding science is to look at its complexity, look at all its various dimensions. Similarly, one could ask the word scientist and inquire into the word scientist. Who is to be called a scientist? Are there qualities which you expect a scientist to have? Or is it just a term referring to somebody who the community calls as doing science? Remember, the word scientist itself is of a very late origin. And it is not something which is, less than 200 years old when it is coined by Wewell, who is a philosopher of science and a scientist, who coins the term scientist to refer to some kind of a grouping. So these are very important questions. There is no clarity to this, and if we think that's a very simple answer to it, then we are mistaken. But there is also another element to this title on saving science from scientists, and that is present in the abstract, which I said. And as Dr. Rajivan mentioned, while the abstract, I didn't know all the earlier discussions they have had here, and maybe part of the my abstract may have seemed as if it's a response to some of them, but that's quite coincidental. But part of the abstract was trying to look at is to understand the reaction and resistance to a study of science among certain communities within India. And I'm fascinated by it as a person who is interested in social structures. I'm interested in what is it that makes a scientific community, the larger scientific community, and within it, of course, smaller groups within those communities, so antagonistic to the study of science, to what is around the world seen as science and technology studies, STS. It's a major program. There are institutes around it. There are hundreds of departments on it. Even small countries which have, a good science practice will have very well programs and departments in science and technology studies, which very loosely includes, history of science, philosophy of science, sociology of science, politics and science, etc. And I use the example of religion and science in the abstract, but also extending to what Dr. Rajan was saying. In India, with my own experience with working with so many different universities, both public and private, if I have found that one of the greatest difficulties in setting up new disciplines or new programs in India today, if you ask me, I would say that the two of the most difficult programs to establish in India today in any institutional setup is one, religious studies, and two, science studies. We don't have major programs in this. We cannot study religion. We cannot study science. And, we are just observers. I'm not saying anything about it. I'm not going to conclude anything about it. It's for all of you to conclude what we want about it. And when I look at it, I'm trying to understand what would be the driving force of this. Who are the people who resist this idea of trying to understand something, which is the most basic notion of science? Forget philosophy. We can, remove this whole discussion of philosophy out of this. The most basic understanding, to understand nature, to understand natural processes. And when we have something called science and we want to understand it, and you need various tools to understand it, What is the resistance within the country to doing that? If you look at all the IITs and ISAs, all of which will, with great reluctance, have the humanities department, even today, with just a few exceptions, I can count them on my fingers, two or three exceptions, they do not, in principle, like to hire people who are professionals in history of science, philosophy of science, or sociology of science. And these are government funded institutions where there is a huge question of relationship between science and society, accountability of what kind of scientific work we do, etc., etc. But still, there is a great resistance to actually taking professionals in these disciplines into that. And I'm not very surprised when Dr. Raju was saying about the reaction of some people to today's talk, and I know this very well, and I know there was something in the Facebook, etc. And I just feel sorry for the people who respond in the way they do, which is primarily through labeling, calling. I mean, this is something which repeatedly happens to me when nobody has the equipment to be able to have a discussion and debate with us, a very polite and civilized form of debate. And the easiest thing for them to do is to call each other left and right. And to me, why I find it so sad is because the people who are speaking on science behave most unscientifically. And this is how I also think there's a parallel with which certain criticism of religion gets particular kinds of responses. So I'm not going to be worried about that or concerned about that, because for me the task here in front of all of you and in my own work in philosophy all these years is very simple. My task is basically to understand the nature of science, to make sense of what is it, how do we practice it, why is it important, who is practicing, etc. And also about reflections on questions of scientists. Are scientists the best judge of knowing what science is? Do they practice the ideals of science all the time? Just because they are in a lab 24 hours a day and it's a very tough work, I know how difficult doing science really is. And does it mean that they understand the larger contours of this practice of science? And that's the question. It's independent of, there are no value judgments on whether it's good, bad, right, wrong. And I think that's just misreading and misunderstanding. And that's really called ideology. What I'm basically asking is, how do we understand the nature of science? What do we expect of a scientist? Does every scientist automatically know and practice these ideals of science, or do they just practice science in their everyday life, what I call as the everyday science, which would be operating some equipments, measuring something, or solving some equations, producing models, doing some simulations, and so on. And this is actually quite a deep question between doing and knowing. And I'm sure all of you have really thought enough about it. But think about all these so many simple examples. There are so many small shopkeepers all around us who are making money in some sense, transacting money, trying to earn something through various business transactions. Now, just because they are so good at it and they survive and do well, would it automatically mean that they know what money is? That they know the basic principles of economics? And I'm not even saying that they don't know. This is an open question, okay? And if you look at a book which Manoj was talking about with Gopal, my last book with him on everyday social, you will see how we also privilege the importance of the knowledge systems in everyday lives of people who are not experts. But this is a question we can ask. You have teenagers zooming around on motorbikes, driving it far better than many other people who can drive a motorbike. But just because they're very efficient in driving a motorbike, does it mean that they know what it is? Is the kind of domain of understanding what a motorbike is, how it works, why it works, does it need very different expertise than doing it? And language is another great example. Almost all of us are very proficient in whatever languages we speak and write in. But how many of us would really know the basics of linguistics, the science of your own languages, the various rules which govern how language structures are formed and used, and various other questions from philosophy on the nature of language itself? So, in a sense, the facile jump to thinking that doing something like going to a lab, working an experiment, or solving some equations suddenly gives you a greater insight into the nature of what you're doing, needs to be thought about. I'm not saying it's not. Obviously, as I said, I know many scientists who are obviously very deep thinkers about what they do. They're very self-reflective about their practice. But most of them whom I know, the people who have really thought about what they do and how they do, very rarely also jump on this bandwagon of abusing others who ask the question of what is science and what is not science. So in the case of science, so I want to pose this question very simply to you. It's a very simple question. So if I want to understand the question of science, I want to understand the nature of science, then I ask the question, how does one study science itself? If you want to say something meaningful about what science is, before you claim that you are a scientist and you have these kinds of faculties of reason or whatever it is that you think you have, the first question is, how does one identify and study science? And so I want to pose a challenge to you, challenge in the sense, in a very friendly sense, is to say, especially for many of you who are scientists or work in science, is to ask, how would you scientifically study science? How would you scientifically, whatever you mean by scientific, okay, use your own definitions of the scientific and ask yourself, how would I scientifically study science before jumping to claims about what science is and, people are anti-science or pro-science. And if I want to look at how to scientifically study science, there are, of course, many people who do it. Scientometrics is one very good example. Scientometrics is actually a quantitative analysis, particularly in the context of publications and so on. I'm sure many of you have heard about, today everybody in universities know about this, citation index and impact factors and so on. So it gives a measure of a way of trying to quantitatively understand not just the quantity of your work, but also the quality of your work. And scientometrics has been very useful. They're very pioneers in India, for example, Professor Arunachalam, who have done enormously important work in evaluating and trying to understand the larger quantitative measures of understanding publications in science, research in science, etc. There are also similar kinds of scientific study of science and science in economics, science in politics and governance, etc. But there are a set of series of problems when we have this kind of a question of what does it mean to scientifically study science. The first point, of course, again something which is very closely related to your philosophical method, if you like, is to say, what is the definition of what I would choose to study? So let's assume we all decide we are going to scientifically study science. So what am I first going to start with? What does science, how is science represented to me? What am I going to choose as being a representative of science, which I can then study? So I could study the practice of science, very well-known examples of Latour and Woolger's laboratory life, where you do an ethnography of people in a lab. There are many such studies after their pioneering work. You can go sit in labs and watch scientists work. You can go sit and talk to theoreticians and talk to them and see what they do, how they do what they do, etc. You could study to understand what your object of study should be. You could study the text of science, but the text of science, whether it's books or publications, etc., may not show you how science is actually done, but it tells you a particular rhetoric of scientific writing, how you make your arguments, how you set up the logic of your arguments, etc. But that is again one aspect of what science could be. You could evaluate how experiments were conceived, designed, and then made operational. That is also constitutes a study of science. You could study the nature of knowledge that is produced in all the sciences and ask questions like Dr. Rajan was saying about knowledge. You could ask questions about what are the structures of justification, how were they produced, how did they get accepted by the community, how were they accepted in the publication, etc. You could also analyze many kinds of scientific enterprises, scientific departments, the subdisciplines in each of the science departments, and ask, did they use a method? Do all the scientists in their everyday practice have something called a method? Do they have a checklist which say, I'm going to do this, I'm going to do this, I'm going to do this? How would you, empirically study the question of method? Or you could try and understand the technological product produced by science. And more importantly, if you want to really understand what things, I mean, each one of these points have been done by different groups of people. That's why I'm setting this out. You could then, if you want to understand the nature of science, you could look at the social practices of science, its institutionalizations. How are they produced as institutions? How are they produced within governments? How are they produced in structure in relationship to the public? What kind of power do they have in societies? You could also look, as many people who study science do, you could look at the kind of people who practice it. Who are the people in all our scientific institutions? What kind of gender and caste compositions does it have, for example? I mean, these are the kinds of questions you could ask in order to analyze what the study of science is. You could analyze, as again a very important subset of analysis of science is, analyze the very close link between science and capitalism, something which is for many people deeply problematical. Okay, and I'll say a little bit about it later on. And that is integral to the practice of science in contemporary societies today. So one has to find ways to reflect upon that. Also, the extremely close connection, again, a very problematical thing, again, a large amount of surplus of amount of literature which have been produced on this, is the extremely close connection between science and the defense industry / military, the military industrial complex, as some people have called it, the extremely close relation between the establishment of scientific practices, the ideas of science, and these kinds of major social institutions. So if you ask me, therefore, given this wide disparity in the way in which science is practiced and science is produced, then the question for me is, if I want to scientifically study science, then given all this, where am I going to start? And I want to go back to the most simplest definition of science. Much before many of these confusions about what kinds of rationalities and logic and so on. A very simple point about science. Something which in the history of science becomes central to the establishment of what today you might want to call as modern science or European science or whatever. Which is the shift from the philosophical, from the quote unquote the rational. Rational here is not in terms of the way we use rational today in ordinary colloquial terms, but in terms of its opposition to the empirical, as a production of knowledge which are not dependent on very empirical basis of various kinds. So the beginning of modern science and its fundamental break with this tradition was possible because of an emphasis on what is called the empirical, right? And empirical, even today, is the most important quality of science, one which distinguishes it from other types of human activities, including to some extent philosophy, and in a very different kind with theology. But the empirical still remains a ground, what you would call as a touchstone of what science is. And to me, the scientific study of science should, if there is anything called scientific study of science, it should begin with the empirical. In other words, if you want to scientifically study this object called science, I begin with the most important tenet of science, which is find a way to study the empirical. In fact, my own work in philosophy of science, a lot of it, for the first book definitely, and even my second book, were deeply influenced as an empirical study of what I did and what I learned as a science student, as a theoretical physics student. So when I did my first book called Translating the World, Science and Language, I was looking at how scientific theories are produced and how they have a relationship with questions of meaning and language, and in particular, of course, the questions of mathematics and the sciences. And my second book called Philosophy of Symmetry really looked at a concept which was very important, which is central to particle physics, which is symmetry, as I'm sure many of you who studied it know, which is one of the most important and exciting concepts. But what is so exciting about it is it's also a central core concept in arts. So when I did this question of my book Philosophy of Symmetry, I was looking at symmetry as a concept in science and arts and trying to understand how do these concepts form, what could these concepts have different meaning. So when I was doing that, I was just doing an empirical study based on the kind of experiences you have in engaging with questions of science. A lot of scientific study of science in this empirical mode can be done by looking at the work done in the name of science, and the ways in which you can do it. You can evaluate what is produced, see who are the people doing science, etc. And there are very many implications of this. Now, in science begins with a very simple idea, right? So you have the empirical world, you have observations which you make, or you make experiments, and then this is the traditional picture of science. And then you may make a shift into theory. You theorize about it. And what do we mean by theorize? And theorize can have many elements. One of the elements is unification. You unify very many different kinds of phenomena into some one common phenomena, and then study it. One of the greatest examples, and when I think one of the greatest examples of human imagination in this comes in the understanding of motion. A very great important insight by Newton on how to understand the idea of motion. Because you ask yourself this fundamental simple question and see what kind of a leap which Newton had to do this, which is, I drop a stone, it falls. And then I see that is movement. Then I see I roll a thing and that also moves. I roll something down an inclined plane, that also moves. I have waves which are moving, water waves which move. And then we had this idea, or Newton was expanding on the idea that the earth also moves around the sun. And the genius of Newton's imagination lies in the fact that he could make a jump to recognizing, to unifying all these different phenomena in different domains. A stone falling, a water wave moving, and then this huge rock called the earth going around another huge whatever thing called the sun. And saying that all of them are the same family, same phenomenon called motion. This is a remarkable jump in imagination. It's not a remarkable jump in some naive idea of logic. And for Newton to be able to do this, and that's why, I taught a course in IISc for IISc students. I just finished this course last month. It was a 3-credit course for their students. And the course was called Philosophical Basis of Scientific Concepts. And one of the things we did was to read Newton's Principia along with Einstein's seminal papers on the first paper on special theory of relativity and his famous E equal to mc squared paper. Now, what is astounding for all of us as we were reading and discussing in the class with a very bright group of students was that the science students who came in with so many misconceptions about science, about physics, about concepts in science were radically, they challenged it. It's not that, they agreed with what I said or what I didn't. My role as a teacher is very minimal there. What I'm saying is when they encountered how these great ideas came about, many of their naive ideas of science, which the so-called supporters of science use today, seem to be quite irrelevant. If you really look empirically at the practice of science and at the way the science has come to be today. And so I only go back to this for anybody who's interested in this subject. Let's look at what is being done before we say anything about it. And those of us who want to say, very good things or critical things, etc., have no stakes in saying this about science, but we are only studying that particular empirical phenomena. So, what the first phenomena, therefore, is you start with the empirical and then you produce the theoretical. Unification is one. Giving causal descriptions is another. Explanations are, all these things about how the relationship between theory and experiment and with the notion of evidence. And so, if we do a simple thing, look at science all around you as empirical observations, as experiments all around you, measurements which have been done. And then I ask you to produce a theory of science. So based on what you see all around you in the practice of science, and you just have to ask yourself, now with all that, can I say something about the nature of science? Can I build a theory of what science is based upon all these particular contributions? Simple. And then we can begin with a simple question. For example, let us assume you're a science student. Okay. Sorry, can you hear me?
Yep.
Hello?
Yes.
Okay. Because I got a message which said close app or something. Anyway. Okay, it says Clubhouse isn't responding. Sorry, 1 second. Yeah, so if I suppose you know physics, let's say you're a good physics student. Now, knowing physics or mathematics, will it help you to build a theory of the empirical empirical data of science? Or would you need to do something else? Would you need other to do that? That is the basic question. So we come back to the question, is a scientist the best judge of knowing what science is? The answer to that is not a criticism of what scientists do. I think, as I said, they do something remarkable. But what they do, does it really help them understand the nature of science? Because to understand the nature of science empirically is to be able to look at a huge amount of natural phenomena associated with science. So, the other disciplines obviously are needed to make sense of it. So, if you look at history, for example, you need history if you want to make sense of this empirical idea of science, because science is a temporal process. There is no idea of science, there's no idea of any human action which is not temporally coded in so many different ways. So you have questions about what discipline becomes called a science. Even you don't even have to go back to ancient India, medieval Europe, etc. You can just talk about science in the last 30 years and look at the number of new disciplines which have been started, number of new subdisciplines of science which have been started. And if somebody wants to understand this question, like, hey, the 30 years back, nobody had thought about this particular discipline, let's say a separate subsection on complex systems, and then you'll have to say, or chaos, for example, and then you'll have to ask yourself the question, okay, in what sense that does this new object also become part of science? So there are very simple, you can of course have simple answers to this. But what a historian does is to draw upon the data, scientifically draw upon archival records. Look at who was the first person who thought of nanoscience really as a very different type of discipline. One of my students in the ISC course wrote a term paper on this nanotechnology. And he actually, very interestingly, he began by looking at people like Drexel and others were the first people who coined the word nanoscience. It becomes an institution, discipline, etc. And it was something very new to him, because although he is a PhD student, has been working on nanoscience for so long, he hadn't really even thought about this whole origin. He was just going to the lab and doing something. And so when his response was that, look, once he started going back and trying to ask, when did nanoscience as a discipline become well established? Who established it? Why did it get established? His understanding of the process of science increases. So just because he's doing lab, knows how to operate a machine and knows something about what he has read about nanotech, did not give him that understanding which he got as a science student when he went back to think and reflect on the historical process of nanotechnology. And this was just as a simple term paper. Imagine if historians of science do it as a profession. And I may be doing some kind of philosophy of science here and there, but I don't know much of the stuff which historians of science do. History of science is such a deep discipline. It invests enormous amount of work in looking at so many records, producing so many narratives and accounts of how ideas of science begin, how scientific institutions get established, and so on. And if somebody is going to sit and tell me, just because I go to a lab or I solve some particular equation, I know more about science and what science is in India compared to the historian who sits and understands it for the last 50, 70 years on how science has been progressed, what policies were done, how did it get established, and so on. It would be very odd to me. It would be very unscientific to me. All I can say is that the scientist who is saying that she knows more about it would be right in that she knows the content of what she is doing, maybe the particular kinds of theories in nanoscience which she is working with. But to say that she knows the nature of science would be untenable empirically. It would be unscientific to say that. So, for a historian to be able to make sense of this long trajectory of scientific thought, the progress of scientific thought, the establishment of scientific thought, which would therefore also include the question, whose work do you want to accept as science? Blacksmith's work. If you look at ancient Indian science, for example, some of the greatest work in technologies around the world in those times came from not very well established, high profile, highly funded government institutions like today, but came from people like blacksmiths and artisans who produced some technologies such as the wuku, the steel making technologies. which were so much in demand that they were exported to for Roman cutlery, to Persia for Damascus steel, the very famous Damascus sword. Now, the point is, a historian who understands this and has worked on it scientifically, in terms of looking at evidence and data, etc., of course has better sense of what science is in the context of whether science was there in other civilizations, whether science was there in earlier times, compared to somebody who's just a scientist doesn't know, what the kind of work which a historian has done on this. Therefore, this question about history is just one aspect of studying science empirically. Then you come to sociology. Sociology makes sense of the sociological data which are essential to scientific practices. Because there is no science, there's something which is very clear about science. And those who want to hold on to some very naive ideological views of science really miss the point about this empirical nature of science, which is science is fundamentally a social process. Science is fundamentally a social entity. Science is fundamentally established through a very unique method of institutionalization. It's something which right from the early beginnings of science we know. The establishment of the Royal Society, for example, which even today is such a big thing because you become a fellow of Royal Society and so on, was one of the most important catalysts in establishing a climate of what is called as science. I mean, Newton was a member of the Royal Society and so on. It establishes the grounds on which you can be called as a scientist. Institutionalization gets practiced in every society which begins to do science. And even today in India, as you will see, some of the strongest scientific, the sociality of science is present through various academies like Indian National Science Academy, Indian Academy of Sciences, and so on. And that is what makes science global, through connection with these kind of institutions. Institutionalization process is an integral part of science. You cannot, if I work in sociology, in philosophy, I can't say much about what science is as if I know everything about it, as if I am the last word on science, if I don't understand the sociological work, which has been extensive work done on scientific practices, scientific communities which do science, these kind of institutional practices and so on. Because for the establishment of science, a variety of things which happen within society. For example, the rejection of scholasticism, a kind of a reaction to philosophy which continues even today in science. The move to mathematics. One might see that as a historical question, and I'll come back to it as a final point when I do the philosophy part of it. But sociologists and historians have written very extensively about how did mathematics become so important to science and what kind of mathematics was used. It's a fascinating discussion. And to me, I don't understand how people say naive things about what science is without even knowing a fraction of this wonderful literature being produced by historians and sociologists. And sociology, in the Indian context, this raises far more deeper questions which sociologists alert us to. Just recently, a couple of weeks back, there was an article by Ankur on Dalit scientists in India. It is an account of a larger question of the kind of exclusions which Dalit scientists face in India, but also drawing upon the story of 2 or 3 Dalit scientists and students who face enormous amount of caste harassment in various of our science institutions. The question of caste and gender in science institutions is integral to the practice of science in India. And if anybody tries and tells you science is just about solving, ax squared plus bx plus c equal to 0 kind of a problem, I think they're really missing the point. They're not doing an empirical study of science. A sociologist who is trying to ask the question, why should this matter? Is it about saying, the caste issues and gender issues? Is it about criticizing science? No. One can look at it that way, but I would look at it as asking, as somebody who wants to understand the nature of science, I want to ask the question, what is it within the nature of scientific knowledge that keeps certain people out systematically? What is it about the nature of scientific knowledge? You cannot talk about scientific knowledge in the abstract as if it's about the sun and the moon without recognizing that there is an integral character to the nature of that knowledge, which seems to have, and none of us who practice, and none of my writings on science will ever say anything definitive. We are always pointing out patterns. It seems to have this exclusionary character. So if you want to understand science, I want to understand, is there something essential to it, integral to it, intrinsic to it, that makes it exclusionary? Or are there other ways of understanding that exclusion? So that's a valid question. At the end of it, you would say, no, no, it's got nothing to do with science. This has happened. That's perfectly fine. But for that, you have to start with this acceptance, right? Before you then say whatever. So you start with your data, then you propose different theories. Absolutely no problem. Science studies is filled with multiple theories of so many things. Not every, although scientists generally tend to look at science studies as if it's all critical of science, it actually shows the richness and the complexity of science. And that's some point which they never seem to understand. So all I'm trying to say is, if you want to understand science scientifically, I also have to look at the data produced by the social practice of science. But to do that, I need training in the tools of sociology. I can't just say, I've been in institutions where, well, retired scientists would just walk in and say, well, I'm going to do history of science today or sociology of science. But you need to have had some training. Just like I can't come and do chemistry if I'm not trained in some basic things of chemistry. You want the physics department person will not allow somebody from sociology to come and say, somebody who can't, there are a lot of social science students are very interested in quantum theory, for example. Try getting them into one of the physics department to say, oh, I'm very interested in it. I want to do quantum theory. Although I've only studied sociology, but I haven't studied physics. So, if this is such a situation, then how do we respond to this? How scientific is that understanding of science, which does not take into account the history and the sociological domain experts, the methodological tools which come from these disciplines? And then finally, philosophy. I don't understand how one can ever understand the nature of science without understanding and using the enormous amount of tools and technologies and methods produced by philosophy. And philosophy and science are a completely different ballgame compared to history and sociology, because as we all know, philosophy has an intrinsically deep relationship with science. I mean, science in a sense is the daughter of philosophy, if you like, but obviously, there's a very strained relationship between the mother and daughter, if you like, in some sense. And part of the problem in this sense is that philosophy does a lot of things which actually science also does in its own practice, but maybe in different ways. For example, questions of conceptual clarification, making sense of playing with concepts, producing new concepts, etc. And philosophy does some of these things which science would do, but the difference, I would say, to put it very loosely and not rigorously, so if somebody wants to disagree with me, you would be right in disagreeing with me, but just to make a point here in a very quick sense, is to say that, well, science is actually far more creative in producing its conceptual domain compared to philosophy. And that is why, philosophy gets left behind in this production of knowledge by science, because and much of it is driven not because somebody sat and said, I am going to do this rationally in a particular way, but because science uses its creative techniques in so many wonderful ways. And it produces these kinds of results and theories and structures in very interesting ways which very few disciplines around the world of humankind have come close to. So, the question which is very common between philosophy and science, of course, and why why you need philosophy to make sense of the data, the empirical data of the practice of science, is to simple questions such as, are there common elements in the sciences? It's a very standard philosophical question. So many disciplines are called sciences. What is common about them? In many of my philosophy of science workshop, I often ask students, science students, I say, well, you say physics, chemistry, biology, mathematics are all sciences. Then I ask them why. What is common between physics and mathematics? Why is mathematics a science? It's not empirical. It's not about the empirical world. It is a language of the empirical world. Then English is also a language of the empirical world. So why don't you teach English? Of course, they do teach English in sciences, I guess. But as a specialized subject like of mathematics as integral to science. And you might think this is just a polemical thing, but this is actually one of the most interesting questions in philosophy of science, or questions of relationship between philosophy of between language and the sciences. And the question of mathematics is a subset of this problem. So, if you ask science, what is it about, what is common between biology and physics? Actually, it's not an easy answer at all. And how would I answer that? You can't say, oh, you're so critical of biology, you're so critical of physics when you ask a question. No, I'm asking the question because I'm observing science empirically. And I'm saying, hey, they're calling all these as scientific subjects. So maybe there is something in common between them. Just like I do when you call so many different objects as tables and chairs and dogs and cats. And I ask them, oh, they're all these discourses which are called science. So what is it common about them? And then I need some tools to be able to answer it. And I can't do it by ideology and say, oh, yeah, if you ask me that question, you're anti-science. No, we are asking that question because we want to understand the complexity of this process of science. And there are some wonderful answers which actually come out. When you really look at the structures of these, today, literally thousands of subdisciplines which are categorized under the sciences. And it's a fascinating question. And the good part of being a scientist is you actually have the tools to be able to answer and look at some of these questions. Even though it may be seen as philosophy, etc. Then I could ask a more important question, which philosophers have often asked when I want to empirically study science. The second simplest definition, first I said one of the definitions of science, which is very true in a very large sense, is science is an empirical study of phenomena. So I begin with observations, I begin with experiments, I begin with measurement, and then say what I want to say. It's empirically grounded. Okay, I grant that, which is true, which is absolutely essential. The second point is, which is also very true, is that they would say science is a study of nature. And you can add various qualifications. You can say it's a systematic study of nature, it is a theoretical study, whatever. It is a study of nature. It wants to understand natural processes, natural phenomena, natural objects, etc., etc. And very rich set of things which it wants to discuss. Science is a study of nature. But when I look at it empirically, as historians or philosophers, we discovered something wonderfully interesting about this empirical study of science, which is one of which is pioneering work on this is a historian Lorraine Daston's work on the idea of nature, the production of the concept of nature in the sciences. A very simple point from that, which we have written quite a bit of that on our everyday social book. You can look at that if you like. But just to give you a quick example, the point is that the concept of nature, if you say science is a study of nature, then what seems so interesting is the idea of nature in physics is different from the idea of nature in biology, and in general it's different from the idea of nature which is produced in different disciplines. So one way to to put this explicitly is to say that different disciplines of science produce their own conceptualization of nature. In other words, they produce what is called the object of discourse, the object they want to study. So the physicist, the nature of a physicist is one that is governed by laws of nature. And that is a production of a community of historians and with a particular social order. It does not just, nobody just got up one day and said, well, it's true that nature has laws. Because remember that when they first started thinking about ideas of laws of nature, which is so central to physics is impossible without laws of nature, there was a lot of problem because the idea comes first from divine laws, then comes into social laws, and then borrowed into understanding nature as nature is driven by natural laws. Now, the laws of nature there, what is very interesting to understand is that the laws of nature are actually give us a very different idea of nature. That laws of nature seem to govern natural processes, just like laws of society govern social behavior. So I have a law of society that I have to pay tax, I pay tax. Whereas laws of nature, like two objects will attract each other, Newton's gravitational law, m1 m2 by r squared, then you say, well, they attract each other by m1 m2 by r squared, and you expect them to get attracted by m1 m2 by r squared. And the question is, who is governing it? Who is making sure that this is going to happen? How do you explain laws of nature? It's such a fascinating question. It's a scientific question. On the same order of asking, what is the law by which two objects attract each other? except that the tools by which you want to answer them, or the kind of answers that you can get. I mean, if you can get a mathematical scientific answer for it, I'm sure it's a great thing to do. But philosophers have taken up this question and they have written about it extensively to try and make sense of it. But in doing so, they're actually eliminating something which science does and goes on ahead with its life without worrying about is it correct, could it be correct, etc. Because science is operational, it's pragmatic, it's a doer. Philosophy wants to step back and ask the various questions about it. A fantastic parallel analogy is the use of mathematics in the sciences. One of the things which a lot of physicists, for example, any of you who work in physics and chemistry or work in mathematical models will know, if you're in physics, chemistry, etc., you use mathematics as operational. You want to see, if I put this in, can I do something? Will I get some result? Can I model something? Mathematicians never do mathematics like that. Mathematicians, to them, what physicists do with mathematics is many times blasphemous. Like when I was doing in grad school my physics, I also was doing a maths course in the maths department, and the maths professor every time used to tell me, because it was part of an internal joke between him and me, physics guys, you are all at the surface. You just want to use some mathematics which we produce on the surface to see if we get a result. But it's only mathematicians who go to the depth. And they will spend time trying to make sense of what physicists have done with mathematical techniques. And that is what philosophy in a sense does, like what mathematics does in the context of physics. Philosophy tries to, science keeps using ideas, keeps moving ahead because it's under so many other kinds of social pressures for its production, including, very entrenched capitalism within it. But it's philosophy and mathematics which will stray back, go back to the roots of it, try and make sense whether it makes sense or not. Again, a classic example of it comes from Newton and post-Newton. The idea of mass and the idea of momentum. Two of the most simplest concepts which you think every science students would know. And as I was doing in my philosophy, my course in IISc, we just spent just on mass and momentum for 2 months. And we recognize how little we actually know, even when it has been written in a particular way by Newton and then later on by Einstein. Newton says something fascinating, and one of my favorite statements, which I think is a very literary statement. When he defines mass and momentum before he starts his Principia book, he says mass is quantity of matter. Matter is not defined. Okay, he has a particular expression for matter, but it's a very ambiguous one. And my favorite statement is about momentum. Momentum is very central, right? Mass into velocity. And Newton says for momentum, if you go back and look at how his definition of momentum is, he says momentum is the quantity of motion. It's a beautiful idea. It's the how much of motion. We don't think of motion as having quantity. Something is moving so fast, etc. But it possesses some quantity called motion. And momentum for him is a measure of how much of it. Just like an object, how its mass is how much of the matter it has. And, he doesn't come back to it. He's not worried about it at all. He does various things with it, calculates hundreds of things, writes a fat book on it, and we all still read it today because that's the foundation of an enormous amount of modern science. It's still Newtonian physics. But just like mathematicians go back and ask whether the mathematics used was right, philosophers go back and ask, hey, what could he mean by quantity of motion? What is this nature of motion that you can have a quantity of it? And how does it affect what Newton does in his understanding of how the world processes happen? And if you look at it like that, there are so many questions which you need to draw upon philosophical methods and philosophical tools in order to understand it, including questions of how do you define scientific knowledge? And, when people, every time they drop these, some of these so-called supporters of science, the naive flag bearers of science, as I would like to call them, they say talk about truth, etc. You just have to stop them and ask them, what is your theory of truth? What do you actually mean by truth? And given that there are many different theories of truth, what is your understanding of the idea of truth in this? I remember I gave a talk at ICER Bhopal because there was a similar question we were talking about. So I titled the talk as truth in science and truth about science as very two different types of truths. I mean, within truth in science itself has different levels of types of truth, and truth about science, understanding the truth about science is leads many different other kinds of truths, etc. And when philosophers are also looking at this question of what is the nature of scientific knowledge, we are also looking at what is happening in the scientific production of knowledge. Every day today, there are over 7,000 papers which are being published. There is research papers after reviewing which are being published every day. You are having 2 papers per minute put into the Nature PubMed, the PubMed, I'm sorry, it's not Nature PubMed, the PubMed archives. Basically, 1 million papers which are being just produced in the archives. Today, scientists don't have time to read papers. They have curators. They have librarians and information scientists who pick out 10 very important papers for them and say, you please read them. You may find this of interest. If every paper, think about this point, right? And ask yourself, how can you be very naive about science if you don't ask this question, which is that if every research paper produces new knowledge, which is the definition of a research paper, every research paper has to have produced new knowledge, which also has some value. That's why it gets published in a journal. If every paper is being published as new knowledge, and you are producing millions of papers every year, millions, that you can't even keep track of them, is there so much new knowledge which is actually being produced? What kind of knowledge is that? What type of knowledge is that? What kind is it? I mean, millions of papers, each one making some new knowledge claim. How do we understand it? It's not a criticism of it. It's not like saying, oh yeah, that's all nonsense. No, I don't think it's nonsense. There are very good established processes by which papers are chosen and published. But what does it say about the nature of that knowledge? And shouldn't scientists who are producing this, who are in this racket of producing it, want to ask that question? And if they ask that question, are they anti-science? But if they want to ask a question, what are the tools they need to ask that question? Do they need to know what a theory of knowledge is? Do they need to look at the empirical data of many different kinds of disciplines which produce these kinds of work? Rather, the easiest way out, the laziest, unscientific way is to just hide under a particular vision of science, as if science is some deductive structure, some very trivial deductive structure, which is producing some truth and knowledge of a particular kind. Nobody, none of the great scientists ever thought that, ever believed that. None of the great scientists who produced very good work in science, who also who had deep thought about the philosophical aspects of science, ever believed in that. None of the great science institutes, which for us is a great model, whether if you want to think of Harvard, Princeton, Oxford, etc., all of them have excellent departments in science studies, history and philosophy of science, as much as they have in physics and chemistry and maths. And yet, we have a handful of people in India sitting and saying, anything when these subjects is all wrong and it is anti-science. And for everything about science, they look to the same universities. So we have to ask this question. We are in that particular situation where we have to look at these kinds of fundamental training in other subjects. Unless I know I have done the basic study of epistemology, theories of knowledge, and different types of theories of knowledge, understanding of the nature of ontologies and what could it mean to understand scientific ontology, etc. What can I say about it? What can I say about the nature of science? If I don't understand this very important question of why mathematics is so essential to science, a question which bothered not just right from Galileo to Newton to Feynman to Einstein. Wigner wrote this very famous phrase, a paper which was published in Communication of Applied Mathematics, where he wrote letters and where he says, he called it the unreasonable effectiveness of mathematics. He said, none of us know why mathematics works in the sciences, but it seems indispensable to the sciences. Without mathematics, there is no science. And he said, I don't understand it. It seems mysterious. Feynman called it spooky. That question, to ask that question, is not to be critical of science. It is to understand the nature of scientific knowledge, that it seems to be so dependent on mathematics, but yet we don't know why. That is the task. That is what these disciplines like history, philosophy, etc. do. And I'm not even going to enter into questions of political science and their attempt to understand the questions of democracy and questions of authority, which are very essential to scientific practice and which do not really happen in the way they should be happening, especially in places like India. So I will end here by just pointing out that a scientific understanding of what science is, which will allow me to make any meaningful claims about the nature of science, needs inputs and training from different disciplines. And who can do it? A scientist can do this, of course, if they definitely draw upon this huge work of interesting work from all these different disciplines. And nobody says a scientist can't do it. But it, given the kind of pressures of science which a scientist has, it's a very competitive, very difficult field, as all of you know. They may not have time to engage with all these different disciplines. So the easy way out is not to say those disciplines don't matter, but to work together and try and make sense of it from different perspectives. We learn from what the historian says, what the sociologist says, what the philosopher says, what others say about it, like what the physicists and the chemists and the practicing scientists themselves say. And that's how we build a picture of science. That is what I mean when I say saving science. I'm not saying scientists can't do science. When I'm saying saving science, I'm saying save the idea of science from very naive reflections on what science is. By authority, which says just because I do something called science, I have the right to understand the nature of it. That's all I mean. And I'm saying to be truly scientific, then without prejudice, looking for the only simplest expression for that, which is what drives all the work I do, is just a search for truth, search for seeing what it is. And if you want to do that, then we have to ask the question, what do I need in order to be able to understand the nature of science? Thank you.
Thank you, Dr. Sarukkai, for the wonderful talk and for asking so many intriguing questions. Shall we get to the Q&A part of this session?
Sure.
Okay, I'll just turn on hand raising here, and while I get people onto the stage, maybe speakers already on the stage can add something, comment, ask questions. Please go ahead. The mic is open.
Thank you, Dr. Sarukkai. That was a very wonderful lecture. I come from a medical background. So, in our social and preventive medicine class, our professor used to say, medicine is far too important to be left to doctors. So, I think it's the same with the science, that it is people sitting in small pockets and doing some science may think that they know everything about science, but they will not have a bird's eye view. Anyway, thank you for the wonderful
Yeah.
lecture.
No, you are right in a sense, and that's why I said after a lot of thought I gave this, because I know the same fight is going to happen, and I'm like quite tired of that stuff. But I also realized the other flip side, that there have been too many people who have paid a price. I have sat with social science students who have broken into tears because they find some scientist mocks their work after they have done PhD work, research, and saying that's not the way to do it, etc. And I've seen this for years now, and I've tried to be in conversation with scientific community throughout my life, right? So the reason I say this, and as you correctly say, it's too serious to be left to them alone, is because not because we all want to think, oh, we want to be science, we want to be called scientists, etc., but because the impact on society by them is so deep, and that there is a huge silent majority which is getting the benefit but also facing the problem of whatever problem there is vis-a-vis that. In India, the social questions around it are too troubling and too deep, including questions of caste exclusion. One might think that's really not about science, but in the Indian context, I think we have to really see what we have done in terms of democratization of science. So you said it very well. So I agree with you on that.
Hi, Professor Sarukkai. Great to have you here. Great to listen to you after a
Thank you.
long time. We met briefly in Isar Mohali a few years ago, at least
Okay.
8 years ago, I think. Yeah. So great to have your thoughts here too. Yeah, I think one of the things, many of the things resonate with my thoughts. What you said, and after coming to Clubhouse, for example, it has been a huge platform to enter into different rooms, hear different opinions on the same platform. And one of the things that I've recently, came to understand is that the notion of people trying to propagate science, taking a very dogmatic position about it, and indeed to popularize it in the sense that whatever science as of today is a reflection of the absolute truth. And that to me is very unscientific itself, because to be scientific also means to be skeptic of the methods that you're using, and unless you
Exactly.
take that position, you're almost like having a dogmatic position on it. That is one thing. The other thing is, and this will lead to one of the questions that I would like to ask you also. And because I'm also a trained physicist, great
Okay.
to have that parallel with you too. And one of the things that Einstein once told, when he started to look at the nature of space and time, is that he uses a sentence that we need to have a definition of what it means to talk about space and time. Yeah, and that is mostly like a philosophical question rather than a scientific question.
Yeah.
Today, people would rather argue that just shut up and calculate. But
Yeah.
Einstein was very specific on the meaning of what space and time means, and thereby reaching. I think it was very critical of him to ask that question to reach the theory of relativity that he gave us. And
Yeah.
Heisenberg very famously told him that he's more of a philosopher than a physicist, which is a
Right.
backhand compliment. But Einstein took it, really nicely, I think. Now, my
Yeah.
question is: are we missing such scientists today? And if so, what do scientists need to do to have at least a parallel thought process like that? What it means when they do something, or is it better to leave it to philosophers of science to think about this and then have dialogues with scientists? If it's the second case, how do we ensure that there are platforms where this dialogue is happening? Yeah, thanks.
Yeah. Thank you so much. I didn't get your name. I didn't get the previous person's name. I can't see it on my screen. Just so that I
My
have. Yeah.
yeah, yeah. My name is Sam. Yeah.
Sam. Okay. No, thank you so much for that, because I think, yeah, you get basically, you did get what I was trying to say. The point is that, there's no simple answer. I don't even want to speak on behalf of philosophy of science, because we have also not done our job the way we should have done, vis-a-vis our engagement with scientists and others, right? And but Einstein's example is a fantastic example. It also answers the question you asked about what's happening in India today. Einstein. So when I taught this course for the ISC students, I said, let's read the original papers for you to see how scientific great ideas in science are produced. So when we did the special theory of relativity, the electrodynamics of moving media, etc. That is the title of the paper, and you will never know that that paper is actually giving you the first examples of special relativity. And if you look at so I told them, we just read the first two sections. Everybody in the class, people who are, I mean, there are many bright students who are doing physics also, were really shocked to see that Einstein's first three pages are actually a simple commonsensical questions on asking a very simple example which Einstein asked, right? When the train reaches a station at 7 o'clock, the clock shows 7 and the train reaches at 7. So two events are simultaneous. What is the definition of simultaneity? What a brilliant, simple, literary, imaginative question to ask. A train reaches at 7, reaches the platform at 7, the clock is showing 7. So there are two different events, the clock reaching that 7 o'clock point and the train reaching the platform at 7. And he says those two are simultaneous. That's what you mean when you say the train reaches at 7. Train reaching at 7 is nothing other than the recognition of simultaneity of two different events. And then he questions the absoluteness of simultaneity. Just everybody who wants to understand the complexity of scientific thinking without reducing it to some naive ideas of so-called logic and rationality, should read Einstein's paper on this. So you're very right. But today, what do we do with it? Most of them, including people who study the theory of relativity, as you also correctly pointed out, will just do some calculations around it. For them to go back to thinking like that, and that's why I did this course by only looking at these pioneering papers, because I wanted them to see how did the first thoughts come about by looking at how, and in every one of them, they were deeply driven by philosophical questions. Not just with Newton, true with Einstein, true with almost some of the major. We looked at chemical bonds and various other things. Everybody, every of these great important things were driven by questions other than some naive idea of science. So, and very ironically, when I was looking for something about this to give the students to read, I came across a paper, a very good paper. It was an excellent one by a very well-known, I mean, physicist, which some of you may know, Unni Krishnan at TIFR. Okay. Now, Unni has written extensively on questioning Einstein's interpretation at a very foundational level. Okay. So he had written a piece on Einstein and Bergson. And I found that and I said, hey, it's very interesting. At least somebody has written it in India. And I knew Unni because when I was at IIT Madras doing physics, he was my senior there. And I wrote, and I met him later, and I wrote to him saying, hey, this is so good to see this and all that. And I mean, I'm not, it's not anything very confidential, but everybody knows. And Unni has said that how the science community within India has always been so antagonistic to the kind of work he does because they think it's some philosophical or whatever, or that he's going to be asking all these questions about relativity. So this is a very big problem, and that's why I don't understand what is the best way to do it. Like you asked, should we do more philosophy of science course? I don't know. I think we need better philosophers of science first of all. Instead of, I think some of the philosophy of science people who have now come are, I would call them as flag bearers. They're just carrying up because they're so threatened by these community of scientists. As I really thought about not doing the talk today because I know, it's the same kind of a question. You would start on it. It's such a waste of time with a group of people who become very aggressive. It's like working with some fundamentalists. So, how do we do this? I do it totally, as I said, by doing all my philosophy of science workshops and stuff. And now I know some young people have joined some of the ICES. Mohali was there, Bhopal, both Rennie and Varun are there now. So there are a lot of things which I'm hoping small changes will happen and maybe we'll do it. But I think just going back to reflective thinking about the basic concepts is a first step in this.
Thanks a lot, Professor Sarukkai.
Thank you.
Thank you. I would like to say two things. As a moderator, it's both in my interest that everyone gets to talk on the stage, but at the same time that we keep our time. So
I'll make my answers short. Yeah. Sorry.
yeah. I was gonna ask if all the speakers on the
No problem.
yeah. I was gonna ask if all the
Just remember
speakers can.
one thing, Professor Sarukkai sir, it's not
Yeah.
from our part. From your side, if there is any restriction of time, that only matters.
No problem. Now go ahead. Yeah.
Yeah.
You are familiar with 7 hours, 10 hours talk,
Oh, no. Okay.
but we'll not extend that much. But maybe 30
Yeah,
minutes
sure.
more.
Let's see if there are, yeah.
Right, sir. Right.
So I was gonna also add that if the speakers, like the people who are asking questions and all, can also say out your name before you talk. So
Yeah.
I guess we'll go in order. So next would be Nitin, and then would be Jamshed.
Yeah, hello, Professor, and thanks, Mr. Rajivan, for inviting me. So, my name is Nathan Thomas. So, firstly, many thanks for the excellent points and intent of the discussion. Jumping straight to the question due to time constraints, even though I have a lot of questions, I would just jump into the question which I find like would be very useful for me. So, myself, being an early researcher in material science, which of course has instrumental links to human civilization and social development, I would like to just ask as a student of science, where should I start from a literature or resource point of view into getting an introduction to this perspective of science? Just like you have directly told a very topic specific resources, but just to start this perspective would be a good start for me. Thank you.
Yeah, now there are a lot of introductory texts on science and technology studies, including on sociology of science, philosophy of science, etc. Well, at the risk of promoting my own work, but I don't want to do that. But if you look at my "What is Science" book, I wrote a book for the National Book Trust called "What is Science," and it is basically meant as to introduce people to some of these ideas in history and philosophy, with also taking into account the Indian context in some sense. And the thing about that book is, it's people have put it up on the net, so you can just download it whenever you want, and there are references in it to some very essential basic text which might help you, because my hope was that you would have a larger discussion of these topics by doing that book. But there are so many now as undergraduate textbooks in sociology of science, for example, and various other people. So you know uh, and what I'm also saying is that, if you need to, please write to us. I have a group of people in my Barefoot Philosophers. We'll be happy to send you material, or give you certain kinds of resource, reading text based on your interest, if you like.
Many thanks. Yeah, I'm just moving back to audience. Thank you.
Thank you.
Yeah, I'm Jamshid. I'm neither a scientist nor a philosopher. And I haven't assimilated all that is spoken in this talk. Yeah, so here's one question. So earlier we had a talk on logical positivism here, which is like a talk on philosophy of science, logical positivism. But like, so the Karl Popper was mentioned not in the main part of the talk, but at some point there's some like reply to your question. And in your talk on philosophy of science also, you haven't mentioned Karl Popper or falsifiability. When I look at from a very, I mean, I haven't read sufficiently on Popper, but like falsifiability looks like a good measure for us seeing if something is scientific or not. Since you
Correct.
haven't mentioned it here, is it that the falsifiability not significant, or yeah? What is your comment
Okay,
on this?
sure.
Yeah.
No, thank you. That's an important point. No, I didn't mention it only because I was not, giving a background to his philosophy of science. I was trying to make an argument about what it means to study science, right? So, what is the methodological ways of scientifically studying science in order to understand the nature of science? So, there are many such kinds of essential points which characterize science. And as you know, Popper's attempt was to find what would be the essential aspect of science, something like physics, in contrast to some in his example, in contrast to psychology or astrology. And falsifiability seemed like an interesting criteria. But falsifiability, although a lot of scientists actually keep using this term. In fact, I was just seeing a news report. There was an event there was some problem which happened to the paper published at NCBS recently, last month or so, and they had to retract it because there was some question of fraud and stuff like that. And so there was an article written by somebody about it, and various things happened. They blamed the students and so on. But I remember somebody who's running the program there, maybe the director or somebody else, saying, "Look, we teach students all the ethics of scientific research. We teach them falsifiability, as if that was the end all of it." And that's a very, it's a very old view of what science is. Today, the way in which science has changed and progressed is remarkable. Like when I was telling you that literally millions of papers are being produced and they're being published, many of them, the kinds of things which I had to learn as a PhD student in physics, which are including analytical solving of mathematical, the differential, integral, etc., are all done by computers today. And the very idea of data has changed so radically. Falsifiability was already a problem post Popper, and which philosophers of science, including Quine and others, had pointed out. The problem about falsifiability is, it's in principle, I think it's a very powerful idea. Okay, and I do think in parts it is a it increases the confidence level in what we are talking about. But does it actually prove what it is saying? So I'll give you one example. Suppose this was the first major critique of falsifiability. That is, if a statement is falsifiable, then what can I actually say about it? So remember, falsifiability was a way of giving us a very robust understanding of the evidence vis-a-vis a theory, the relationship between a particular evidence in support of a particular theory. So the first criticism of it came that falsifiability, you cannot do a one-to-one match between evidence and one hypothesis. Let's say you want to falsify an hypothesis, but every hypothesis comes with a network of other hypotheses, auxiliary hypotheses. So when I might want to falsify something, you're also falsifying a large number of other kinds of auxiliary hypotheses necessary for it. Let me give you a very, very bad example. Bad example in the sense it's not very well thought out, but just to make this point very quickly, that suppose somebody says the earth is flat, and then you falsify the hypothesis and you show that no, the earth is not flat due to some evidence or some observations that you do. Now, the point is that my hypothesis that the earth is flat needs various other hypotheses to support it. For example, the definition of flatness, the definition of the belief that my instrumental perception, or if I'm talking about my eye perception, that it is not going to, there are other assumptions to do with just observing the flatness, etc. So the one-to-one correspondence was called into question, and that remains, I think, a serious, in a sense, a kind of a problem. But today, with the kind of digital and visual techniques which are endemic in the sciences, this question of falsifiability becomes, it's only scientists who like to keep using this repeatedly. But I think there are major philosophical questions which have been raised and discussed, but which no scientist wants to take time to at least flip through or read. And that's my problem with it. They can reject anything which the philosophers of science have said. They are welcome to do so, but they will do it without reading it. That's my only problem about it. But there are, these kinds of criticisms about falsifiability.
Thank you.
Thank you. Next we have Rahul. Then comes Jared.
Thank you, Rajiv and Sriram, Manoj, for giving an opportunity. First of all, it was a very neatly constructed, well-knitted lecture. Thank you, Mr. Sundar sir, for your time.
Thank you.
Pleasure asking question. So I am one who believes that philosophy of science to an extent is required, mostly in framing the right questions at each stage of a scientific quest. But at the same time, I'm aware and has read physicists, scientists having their own positions. Like recently read about Richard Feynman's quotation where he says that the philosophy of science is as much use to scientists as ornithology is to birds.
Birds, correct? Yeah.
Right. So possibly there is a fallacy of false analogy in there, but keep hearing physicists saying that. So my question is basically derived out of all these readings and understanding I have about it. So it's a very simple question. So philosophy of science is understood in a way, to be there to scrutinize science, to keep science from deviating from its fulcrum itself, to keep science in check. The whole idea of falsifiability, empirical measurements and all. So what is there to scrutinize the philosophy in itself, which is formulated to keep the science in check? That's my first question. Second question is a very, a question from the ignorant who don't know the subject philosophy itself. What is the difference between a scientific question and a question raised by the philosophy of science?
Okay.
These are questions.
Okay, very interesting questions. Very quickly, let me. If I start talking, I may do for another half an hour on this itself. So let me give you a very quick point about. The first point is philosophy of science does not attempt to constrain science. Or what is the word you used? Did you say constrain or
scrutinize or to keep
scrutinize?
In check?
Yeah. Okay, no, keep in check. No, definitely, philosophy of science task is not that at all. It doesn't scrutinize science. There are questions in ethics, for example. Ethics is a subdiscipline of philosophy, and which there are questions raised on ethics and science. But that is not about scrutinizing or keeping in check or anything of that kind. And that's why when people look at philosophy of science as being anti-science, I'll give you one example, a real life example, which happened with me when I first joined NIAS still as a very young faculty. There's a very well-known scientist also was there. And once he was asking me what I was working on, and that time I was very interested in this question of the existence of mathematical numbers. And that's a typical philosophy question. It also answers your second question. So philosophy of mathematics is a very important question, which is also related to what is called Benacerraf's question, etc., which is about, are mathematical entities real? Do they exist? And if they exist, then they cannot exist like chairs and tables, because like numbers 1, 2, 3, 4, etc. have supposedly, according to Platonic doctrines, an independent non-spatio-temporal existence. And this question were framed by philosophers of science, particularly Paul Benacerraf, asking how is it that spatio-temporal objects like the human body can have any connection or knowledge of these abstract entities, non-spatial objects, are called mathematical objects. That's all. Simple question. So I was telling this person, I'm looking at that. I think there's something interesting I want to pursue there. And the first response that person had, who was also a very good friend of mine, by the way, in the sense much senior to me, but very well disposed to me. But you know what he said? He said, Sundar, why are you so anti-mathematics? And it was shocking to me because, that question is not about constraining mathematics or of saying that you can't use mathematics. It is a philosophical question about, because what, and that answers your question about the second point. What do I mean by scientific question and philosophical question? One of the first things which we have to recognize is every discipline creates its own objects of study. I said nature, for example. Physics defines nature in a particular way for use for itself. Chemistry defines nature in a particular way for itself. Biology uses it in itself so that it suits the aims and goals of that particular discipline. So similarly, the philosophy has its own set of vocabulary and tools and terms of discourse or objects of discourse that it wants to study. So science never studies, for example, science never studies a chair. So I can have a chair in front of me. You can't say I can have a scientific study of chair. You can only have a scientific study of chair if it reduces a chair to an object, to a scientific object it can study. So for example, the earth going around the sun, it's not physics. Newton is not studying the earth going around the sun. Newton is studying only the idealized point object called earth going around another point object called the sun. There is no size, there is no fire, there is no heat, there is no smell in that description. So you prepare an object for it to be amenable to be studied. So physics prepares its object in a particular way through idealization and abstraction. So sociologists will not do that abstraction in that particular sense. So people who study, for example, philosophy of the body will begin with the body. They will not abstract it by a point and say an object is moving from point A to point B. So this is the crucial point. So the quick answers to you is, the second point is about how we prepare our own objects of discourse and then use the tools of the discourse. And the first point is about how philosophy is really not about constraining or putting any kind of thing. It's not just Feynman. Everybody, Weinberg, Hawking, everybody has dished philosophers of science, saying that they are, what do they know about science, etc. And I agree with them. I'm saying philosophy of science is not in the task of doing science. We are interested in the task of understanding the foundational nature of science. We are in the task of knowing, are your concepts you are working with meaningful? What do they actually imply? And with respect to certain philosophical questions, for example, of the nature of existence. So for example, when I was doing physics, we studied all quantum electrodynamics, photon, etc. And it was all not funny, it was like an odd thing. Electron, wave particle duality, and photon has zero mass. Okay, so it does not have matter like any object, but yet it is a particle. All these kinds of questions were there, and it all became just science fiction at some level. But philosophy is going to go ask that question about the nature of existence of a photon. Does a photon really exist in the way an object exists? How does an object which is supposedly having zero rest mass exist in any sense of the term? How do electrons exist as an object? Very simple. Those are the philosophical questions. Science is not asking that question, what is an electron? Remember that. It's a crucial question. What is an electron? Where is the electron situated, how does it look, is not an important point, because for science it defines objects in terms of its properties. As long as I can say that it has a negative charge, spin half, etc., that is the definition which is needed. But when we talk of a chair, it has properties like color, shape, but I also talk about what philosophers call haecity, being there, some kind of an existence. For science, existence is not a relevant question to ask. It doesn't matter, especially with complete subatomic physics, etc. I mean sciences. So these are very important questions. And I still think, even though people may say we don't need philosophy of science, etc., it is an important question to ask: is a DNA real as the people who say it is? Is a coronavirus really like what they draw pictures of and give colored thing with all the head things protruding? What does it imply? It's not even a question of doubting the scientist. It's like asking, what does it imply about the nature of objects in my universe? So, very rich set of questions which philosophy of science can ask when it engages with this question.
Hello, Professor Sarukkai.
Yeah,
My question is, how do you actually deal with the conflict between the different traditions of philosophy itself? So, especially
yeah,
when someone like Chomsky and a lot of analytical philosophers, for that matter, look down upon the continental tradition. Now, these are
yeah,
philosophers, Chomsky, for example,
yeah.
who uses a lot of analytical philosophy in his knowledge search. Then there is the Sokal affair, the Chomsky-Zizek debate. So, how do you look at this?
Yeah, okay. I think that's a very fair problem which many people face. I mean, among two questions which a lot of people face when they want to do philosophy of sciences, they ask, should I know science before I do philosophy of science? And then second question is, what tradition should I be doing, etc. Now, for me, um, I can only let me share my own approach to this question. Okay, for me, everything I did, all the major projects which all became a book on a particular topic, were all driven by something which I wanted to know for myself. So when I wrote my first book, Translating the World Science and Language, that began by a very simple question I had, which is, how is it that I was reading science books, textbooks? What kind of theory of meaning do I need to make sense of what are called multisemiotic books? Because there's one line in English, then on equation, then a graph, then some more English, etc. So what is that relationship? So how do I make sense of it? And for answering that, I actually went to translation studies. I learned translation studies. I didn't even know there was a discipline called translation studies. And then I did all that stuff and looked at the whole book on how to do, translating the world's science and language. So what I'm saying is, for that, I was looking at the question of meaning, and I drew a lot from continental thought, including theories of meaning, etc. But for me, the question is, I don't have any commitment to a particular tradition, because I am, in a sense, I'm trying to find an answer. I'm willing to use tools in whichever discipline that I want in order to answer that particular question. So when I did Philosophy of Symmetry book, the first part of it is completely from analytical philosophy on parts, classes, mereology, etc. Because it's about set theory and groups and so on. And I felt that that was the best way to understand that, and I used it. And when I did my third book, it uses Indian philosophy. It's called Indian Philosophy and Philosophy of Science, which looks at Indian logical tradition and Indian philosophies of language in order to understand how it is very important. It offers a new, different logical structure to understanding science, contemporary science. So, my answer to what your question is, I think, being open to different traditions of thought is a very important thing. And part of the problem is about philosophy itself. We have reduced philosophy in a large extent to something, to history of philosophy. We think philosophy means is about philosophers. So we have reduced philosophy to saying, what did Heidegger say or what did Husserl say, etc., which is important. It's one part of philosophy, and there is a good historical reason why that happens. But to me, I think philosophy is a kind of a tool for my understanding. I don't know if others understand it, it's fine, but I'm just doing it. So for me, traditions don't matter. And I think all traditions have their own strengths and their own limitations. So depending on the kind of questions I want to look at, I want to explore them in that context. So I don't know if I answered you, but at least I can, I feel that one has to be very open about moving towards looking at philosophy as a set of ideas rather than get stuck with one author who and keep reading their book for years to come.
Thank you, Professor. Thank you.
Thank you, Doctor. How are you doing on time and like in terms of questions?
I
Have
think
How
you,
many questions
what?
are there? We can
I
go on till 9 for sure. We have
yeah,
another
Okay, okay.
15 minutes, so let's
we
see.
can take all the questions from the speakers in the speakers panel right now, I think.
Is there a speakers panel? I can't see.
Sure. We have about 6, 7 more people on the stage.
Okay, sure. Let's finish that then.
Or
Yeah.
Sure,
or
sure.
we
So,
can collect a couple of questions together and answer them.
Okay, yeah.
sure. We can do that then. So maybe 3 at a time. So Kiran, Sangeet, and Janya, can you briefly ask those questions?
Um,
That'll be great.
Hello, am I audible?
Yeah.
Yeah, Professor. So you mentioned the work done by Bruno Latour, laboratory life construction of social facts. So
Yeah.
I would like to know your current perspective on the socially constructed nature of science. And if that is the case, how do you see this kind of socially constructed side of science and selection of scientists? What kind of credibility as scientists should have in the context of India? But particularly, I see that you have done a lot of amazing work with people like Gopal Guru on the discriminated people or people who are untouchables, Dalits, and all those kinds of people. So I would like to know how do you see this kind of work? I mean, social construction of science in the
Yeah.
context of Indian realities like caste communities, this kind of tribals and all. So discriminated
Okay,
communities.
yeah.
Thank you. Thank you. Yeah.
Yeah, again, a very difficult question. Because I tell you what, I mean, I think the social construction program, the social constructivist program, which had a heyday in the 80s and 90s, was an important moment because it brought about new challenges to the hegemony of certain knowledge systems. It made them ask new ways of questioning certain kinds of exclusions present in science, etc. And we should remember that one has to ask that question about science. We haven't, I mean, none of us have asked that question so far, but we remember, for us it's important to ask that question because it's not just about the exclusion of women and Dalits and the other castes in Indian context. It's also the fact that there is a very deep and troubling relation between science and capitalism and the military enterprises. So, that is something which all of us, and that's why many times I'm very confused when the Indian left does not seem to recognize in their very blind support of some very old models of science seem to miss this point. Because for me, I think, given my the fact that my inclination is all towards the left, for me to find that there one blind spot where I cannot talk to them about is actually around the question of science. And I find that a very deep troubling spot, mainly because of its very deeply troubling science's deep relationship with capitalism. But anyway, the point what I'm trying to say is, so social constructivism in that sense was a good start of a particular kind of a critique. But I don't think it was sufficiently philosophically grounded. When I mean philosophical, I don't mean some kind of value to the discipline of philosophy. What I mean is it has to have been grounded in a way with far more critical reflection on it. What happened is it got hijacked more by literary studies and culture studies and so on. And I think what we could have done with it was sort of lost out. To me, it's always an important question to give examples in a simple way that I can engage with anybody. So, for example, when I do believe that for example, the feminist critique of science are often like, the men would immediately say, the scientists would say, oh, if women did science, would they have done a different science? And I would answer as yes. And then the next question they'll say is, well, would Newton's laws be different? And that's a wrong question to ask. Maybe Newton's laws will not be different if you start with the kind of conceptualizations and assumptions that Newton did. But the point about feminist science, or about Dalit science, or other kinds of approaches, subjective approaches to science, is to say that the assumptions which is needed by Newton to reach his Newton's laws need not be there. When I change those assumptions, when I change the conceptual structure, what new ideas will I get? So, to me, to that extent, there is an importance of it, but to reduce all reality to just this kind of a discursive nature, which also became a correlation of the social construct, is something which I have a problem with. Not as much in science, because science is a discursive enterprise completely, particularly with mathematics. But more in the question of my work with Gopal about caste, what we repeatedly encounter in all our formulations with it, including in our new book on everyday social, is that caste is ontologically and very deeply grounded. And for those who claim that it is all in the mind and caste is a social construction, is something which we have taken a stand against, in the sense that there is a experiential basis of the questions of discrimination of caste and caste ontologies in our society. So I would say that we have, two different ways of looking at it in these two domains.
Uh, can I go next?
Yeah.
Hello, sir. Thank you for that very well laid out presentation. You kind of prefigured a lot of things I've been thinking about, and as a student from a background of physics and political science, who's now looking through as many fields as I can to figure things out,
Okay.
I just my one of the things I'm currently thinking about is how especially you mentioned the paper on by Ankush, if I'm not mistaken, on the experience of Dalit scholars, Dalit scientists in
Yeah.
India. So this idea of scientists as bureaucrats and how the mixing up of science and bureaucracy, especially say in India, has created these structures of exclusion, and how it associates with projects of states and so on. So you ended the talk on questions of authority and power, and I would like maybe perhaps you could talk a little bit more on that. Thank you.
Yeah, the question of, there is a very troubling question. And again, when we talk about this, we have this the science brigade immediately jumping on us. So, but it is something which we have to look at it as a fact of the world, and we have to give an account of it or make sense of it. It is that the science community is perhaps the most articulate and the most visible community and most powerful community in the country, which has been consistently against reservations, which has been consistently evoking a particular notion of merit. And to the extent that much of the science institutions, the majority of the people in science institutions are from forward and dominant castes. And the question is, in a government setup where we are mandated to have reservation, you still have exceptions in science institutions. Even in the Dalit, one of my friends who has shared the Dalit article, Vankur, was saying that even with that article, the immediate response is, these are just some examples of individuals. This has got nothing to do with science, or maybe they are not good enough, and that's some, the usual kind of stuff. And however much we have written on and tried to converse with them, that the very idea of merit is, is in this sense, to use the previous thing, very socially constructed. There is no natural status of questions of merit, and that it has been very discriminatory and exclusionary. They just don't seem to get it, both with the questions of gender and castes. And so I think that's a extremely difficult problem. And the fact that if anybody raises these questions, they're immediately called as anti-science, has become a very cheap tool in their hands to not get any discussion on science. Or worse, not just anti-science, today anything you say, you are a rightist. I heard the Facebook post on today's talk was that, I'm a closet rightist, because they know my public fight against the BJP and stuff is very well known, and I've had to pay a price. But it's very easy for this person to say, "Oh, this guy is a mask hiding his rightist tendencies." Beyond a point, I find it's ridiculous. They are so not, other than everything else, very unethical in that writing. They're also so unscientific for what they think they're standing for. So this is a problem. It's impossible to talk about this question, to the extent that if you look at the major science institute, like somebody was telling me this about TIFR, the administration has a reservation policy, but the faculty will not have reservation policy. These are questions which one has to ask. And for me, the question I've been asking is very simple. By doing this, have you actually kept out some of the most creative minds in science? Have we, because science is far, see, my problem about this packaging, ideological package of science in this some very vague notion of rationality or logic which they try to associate it with, is the fact that it is not true to the empirical way in which science has been conducted. If we had opened it out, if more communities, if more gendered and caste practice, if science had been truly democratic, which is the essence of science anyway, the real ideal of science, which is such an important aspect of science. If we had brought it in India, we should have opened it out to people from villages, from all kinds of communities. And I can guarantee it, give it to you in writing today, we would have had a far more creative science produced in India. Otherwise, we are like the Olympic thing every year, getting so we're happy with one or two medals here and there. So I really think that question of this attempt to take over power within their hands. Scientists are very powerful in spite of what they keep telling us. In all the scientific advisory committee, the PM's advisory committee is headed by scientists. They are now advising the government on everything. It's not just about science. They are advising them on military. They're advising them on education. They're advising them on poverty alleviation. They're advising them on how to get water. It's not the social scientists who are doing it. In that kind of a power that they have, they've also been able to keep it as a very closed, exclusionary kind of a community. So we have to ask, why did they get these notions of authority and power invested in science without accountability? That's a question, which we need to really find ways to ask without criticizing them. We are just saying it has to be hand in hand. Why is it that nobody's asking the IITs and ISERs and all the government institutions that why you will not hire good social science people in your institutions? Why is it so difficult to do that? When they are publicly funded and when they are supposed to be mandated as science and society, you have retired scientists or other scientists beyond a particular age saying, we will do all of this. We will teach ethics. They won't hire a philosopher person to do ethics. And nobody's asking that question. I think it's a default of the social science community itself, which has been silent about this major problem in the Indian science community.
Can I go next?
Go ahead.
Yes. Hi, Professor Sarukkai. I'm a student of Dr. Tarun Menon at NIAS. So I'm currently doing my PhD in the US. I'm very glad you brought up this topic of the higher education reservation and no reservation in the faculty and research program area, because I'm writing a paper on that, where I'm not sure if you've read, there's a new book by Dipanvita Dasgupta, Creativity on the Periphery, where she
No, I
talks
haven't.
about how the cognitive workings of a scientist in the peripheral part of the world are different and need to be studied under some sort of a framework. And she uses the idea of trading zones between like a core and periphery and how the knowledge is traded. And I'm sort of extending that idea beyond her. She's looking at colonial India with C.V. Raman and, the M.N. Saha, all those people. But I'm extending it beyond that to, kind of argue that there is a zone that existed within the zone. That zone was mediated on caste lines, and it was much less permeable and porous than the colonial and Indian, the British and Indian zone was. And the reason for that is that sort of Brahminical vice grip that has continued. And then I'm using some of the data that you just mentioned about IITs. So I'm wondering if that is something that we need to study more about, because history and philosophy of Indian science itself, we do not teach history of science as a discipline in India. So if that is, I'm very glad you brought up the topic. So I just wanted to mention.
No, thank you. I'm glad to. I look forward to reading your work on this because it's a very important question. I don't know if you have seen, T.M. Krishna's book on Sebastian and Sons on the Mridangam makers.
Yes, yeah.
Yeah, so I wrote a review for it on EPW, and one of the points I make is something very similar to this because you see, the point is there is a lot of knowledge based skill which is present within the makers, which becomes very important for what the musician is going to do. So the hierarchy there was very simple. The musician is a Brahmin, typically in the South Indian context, Carnatic music, and the makers were Dalits because they're working with cow skin, etc., and buffalo skin, and so on. So the question there was whether there is any correlation between the two, and I think T.M. Krishna was not interested in it, or is not, didn't have, perhaps have the tools to really push at it. And that's the point I had made in my review, that that's a very important question because uh, is the quality, because the typical answer to this by, let's say, the musician, the upper caste musician. I'm saying this example because it's the exact parallel with the Indian science community with this question of caste. So the response of the musician is to say, look, they have produced the mridangam, but I am the one who's producing the sound in it, and I'm the one who's playing it, and I have learnt it. My learning, that science of music which I have learnt, is what is producing the mridangam sound. But the point is, in mridangam, without those people producing that particular machine called the mridangam, there is no way they could have produced the music, even though you had a science of music which needed to be taught as a shastra. So I'm very curious to see where your work will take you, because I think it's a very important question to ask. In the Indian context, of course, our science establishments post independence have been quite isolated, have been they've been very clearly demarcated on caste grounds, and so their engagement, as in the earlier times, to use Peter Gallison's work. I'm sure that she's also using the same thing on the
Yes,
trading
yes.
zones from Gallison.
Gallison, yeah.
Yeah, so the caste trading zones, you may see maybe perhaps in instrumentation, again to use Gallison's point, between the instrumentation community and the experimental community or the theoretical community. But it will be very difficult for you to find it. But I think within science institutions, but within the larger society, you would see a lot more of it. You see a very vibrant thing if one can tap into that knowledge system. But yeah, I think the fact that they were not part. I mean, even today, if you look at the number of Dalits who are in science institutes, is abysmally low. And the Ankur's piece also is pointing out. I mean, it's maybe in many places, maybe one or two in science research institutions, and there are some very deep questions about it. And there are also questions of the pressure on the Dalits to perform like the others in order to be accepted into the science institute, all these kinds of socialization. So yeah, it would be interesting to see how you convert it into the question of science. I think the major challenge you will also face is this, that the production of knowledge by other communities are not seen as science. And that's a big
Right.
problem with Indian science, right? That's the biggest problem. Once you accept that as science, then you can look at trading zones. But now, if you don't even accept them as being part of what they produce, as being part of the world of scientific knowledge or world of science, then you will run into other kinds of problems trying to justify that. But yeah, it will be an interesting thing to see where you go with this.
Thank you, thank you. I will work on that, and I will probably email my paper once it's done.
Sure, I'll be happy to read it.
Next up is Rajesh, and then comes Anjana.
Yeah. My name is Rajesh. I teach sociology. Thank
Can
you,
you
Professor.
speak closer to the mic, please? Thank you.
Yeah, my name is Rajesh. I teach sociology. And thank you, Sundar, for that wonderful. See, my question is largely from when I was doing PhD.
You're breaking up, Rajesh. I can't hear you clearly. Sorry. Can you?
Yeah, is it clear now?
Yeah, better. Yeah, yeah.
Okay. So when I was doing PhD at
Hmm.
Hyderabad University, 2012, I have a good
Rajesh, your voice is breaking up. Rajesh, maybe
Yeah.
you try after the next speaker, and maybe try another device or something, if it is
Yeah, sure,
okay.
sure. Yeah.
I guess we'll move to Anjana real quick. Yeah.
Yeah, thank you. It was a really nice talk. I really enjoyed a lot of points in it. I'll just briefly introduce myself. I'm Anjana, and I'm a PhD student. Yeah.
Okay.
So my question is, so it kind of came up recently because of the talks that I have been attending in Clubhouse. It's two questions, but it's really linked to each other. I would think there are people who think differently. Uh, so, um, so the first one is: does a scientist need to look into philosophy to actually deeply understand science? Does
Yeah.
the scientist have to do it? And
Yeah.
also vice versa. Does asking philosophical questions and questioning science and existence itself make a scientist a less of a scientist or an anti-scientist? First.
Well, thank you. I think the second question is the first. I mean, I can. Okay, let me take it on the order that you asked. I don't think scientists have to ask very deep philosophical questions in the way philosophy might want to articulate those questions. So, what I mean by that is that philosophers might say a true philosophical question is like this. Scientists don't have to ask that. And the point for me, when I was, for example, teaching Einstein's paper, was to tell the students, look, how will you start thinking about? For me, a lot of philosophy is just about thinking. So I don't. That's why it doesn't matter which tradition it is, as long as I can think through it and understand it. So for me, the question was when Einstein is beginning with this question, he's actually not even asking these very deep questions about time, etc. He's just asking what is simultaneous. It was a very commonsensical question, but which he dwelt in very deeply. To me, a lot of critically questioning the foundations on which you stand in is already a way of doing philosophy. Now, when you start asking those critical questions, philosophy has already done that job, and therefore it has ready-made tools to do that. And that's the only context in which one might want to do it. But I must also say that you have excellent scientists who don't know anything about philosophy, and they're very good scientists. And their task is to do that science. So my point is not about that at all. I don't think doing philosophy of science will make you a better scientist. In fact, for me, the reverse happened. I started doing philosophy when I became also went to the philosophy department while I was doing my PhD in physics, and I was very always been drawn to philosophy. And then I decided at the end of 5 years of doing philosophy, I said I want to do philosophy itself as a thing. It's not that it made me my physics was any better because I did philosophy, etc. So I think the task of doing science is very clear, which is very different from the task of doing philosophy. So I think much of it is only about one's own push for it. So that would there be a very clear answer to that. But second question is, yeah, why would they, if scientists ask these questions, why would they look at anti-science? And that's why when I did this course for IISc, I called it Philosophical Basis of Scientific and Mathematical Concepts, in order to show that some of the most creative scientists who actually came to their work by asking very profound philosophical questions. And it was a way of hoping that, guides, etc., will be less harsh on students who want to ask these foundational questions. Many times they ask, they'll say, if I remember many years back when I was at NIAS, a physics professor there and me, we wanted to offer a course for the physics department at IISc in philosophy of science, and the department committee meeting said no, because they said you do this physics philosophy for the students now, it will spoil their head. And so now after so many years was able to do this course for IISc now because of the undergrad program and so on. But what I'm trying to say is it is I don't understand why they would say that. I really think deeper understanding not just of philosophy, deeper understanding of human creativity, psychology of creativity, sociology of behavior, within, as I said, with gender and caste questions, and understanding all of Indian sociology is such an important aspect of doing science. And to think that science is only reduced to some kind of an equation or some lab work is to really miss the point about the richness of scientific thinking.
Thank you, sir.
Thank you. Before we go to the last person who joined from the audience, who's Prakash, shall we just go to Rajesh again? Rajesh, can you hear us?
Yeah, yeah. Am I audible now?
Yeah, much
Yeah,
better.
yeah.
Okay, okay. See, my question is largely a commonsensical in nature. See, when I was doing PhD at Hyderabad University from 2006 to 2012, one of my friends who was doing a PhD in physics, and he was every Sunday is going to the church by carrying a Bible. Then I asked this question that see, Bible is giving you a particular kind of description about the origin of Earth. And similarly, see, if you go to physics, physics is giving another kind of a scientific explanation. So, how do you combine these two things when you are as a social being or whatever it is? So, my question is this: see, he was giving an answer that is something. The other one is personal, and the scientific explanation, which is part of my career in science. So my question is how this is possible that a neat distinction which people are making, this is personal and the other one is professional or profession in science. How do you look at this issue?
Okay, again, a very difficult question. The reason is because, I mean, the example you give is a difficult one because we know, for example, that the so called religion science debate is actually based, people often talk about how it creates modern science, etc. In the case of Galileo, for example, or Copernicus. But Galileo's fight with the church is based, I mean, the real problem with science and the church begins because of the exact question that you talk about. When both are talking about the same phenomena but with different answers, right? But a lot of religion is not about describing the same phenomena. So there's no conflict of interpretation. Then, science is actually quite indifferent to it. And Galileo's closeness with the church is also well known. So the point is, I don't know about your friend. I mean, is there a conflict in when, as a physicist, he learns something from the physics lessons and then the Bible thing? So, to one of the ways of reconciling that could be to say that I don't, necessarily buy that story in the Bible about the earth and the sun. Um, just like he may not buy all the stories which you get from physics, for example. You may not buy the story about photons existence in some sense. I don't know. So yeah, there is a conflict, but I think this question of personal choice, while it is true, in other words, we would call it as the interior world versus the natural world. And one is a description of the interior world, one is a description of the non-human world. And that's a very fair distinction. And you could say religion is for me to negotiate a technology of my inner existence, while science offers me the technology of manipulating the outer world. And then it would be far more difficult to this one. So, but I think in general, it's not just about your friend. A lot of scientists are able to do this compartmentalization. So there are very large number of scientists who are very deeply religious believers, and they might do certain kinds of prayers, and then they'll come and do their lab work, do their math work in other disciplines, and so on. So this has continued, and I think the lack of understanding the complexity of this relation has also led to very naive reading of scientific temper in terms of just pure atheism. So there are other kinds of questions which actually this raise. It'll take us a lot more. I mean, it's a very interesting topic, but this is a quick answer from my side.
Okay, okay. Thank you, Sundar.
Thank you. Next up is Prakash.
Yes, really want to thank the forum, Rajivan sir, for inviting me, and Professor Sundar Sarukkai for the excellent topic of debate. I personally am a plant biologist, a scientist, or I also think of myself as a part philosopher because I ask some deeper questions in biology. I don't do mainly application science. So I have two questions. One is, if you look at the evolution of education and learning, methods of learning, would you be inclined to accept that science and philosophy were in the hands of the same people, and eventually it got demarcated as two streams during the evolution of our educational process and understanding the world through scientific method. And the second question is, how will philosophy help in clarifying um, scientific concepts, and in terms of how it is being educated? Like, where should we start teaching philosophy in the current times of our evolutionary process? Where should we
Okay.
start teaching philosophy?
Okay. Again, very interesting questions. The I think the point is where although science and philosophy did have. I mean, I'm trying to focus on the question of education rather than the discipline itself, because we know science and philosophy were in some sense closely connected and so on. I think in education, in the Indian context at least, we have completely destroyed philosophy education. And I really think, I mean, I think the philosophy community, I mean, has suffered. I mean, there's been various reasons has happened in this for this. So the real question for me where this teaching has to happen, which also addresses your second question, is it has to happen at the school level. And when I say this, people often get very upset and say, I remember I gave a talk where Krishna Kumar was chairing it in Delhi in the India International Center. And at the end of it, he said, oh, you're now putting more burden on students by saying they should have other than one more class on philosophy, other than all the other classes they're already burdened with. But my point is that, look, philosophy is already present in most of the subjects that you are teaching, and it depends on how we find a path towards thinking in those particular directions. So in fact, that was the reason why my latest work, and something which I've been doing for the last 2 years, is doing philosophy workshops for children. And the book which is come out in Tamil but will come out in other languages is called Philosophy for Children: Thinking, Reading, Writing. And I learned a lot when I did these workshops for these children, because it was amazing how they were able to raise this kind of questions. Like when you said you are asking these questions in this philosophical sense, even though you're working within biology, it is amazing how these kids, and I'm talking about 10 to 12-year-old kids, and that was my target audience, 5th to 7th standard. And they were like, really, I found there's a very organic connection to various forms of philosophical thinking at that time. And then when we introduce scientific ideas to them through this, they become more critical thinkers of science. To me, the point about doing philosophy is not to ask scientists to do philosophy of science or even philosophy. And I really think it's about inclinations and what kind of questions we like to ask. But definitely opening up the space of thinking about it. My problem is today in a lot of science teaching, we are just teaching them like religious texts. I've been working with a very good science educationist, Anu Joy, when she was doing a workshop for Telangana teachers. So I did this for the science teachers. So at that time, I asked them to send me this physics book. And I was looking at it and I was trying to tell them how that book should be taught. And I was looking at those texts. These are very good produced texts, even NCRT texts. And they are teaching science like, to put it very mildly, they're teaching it like religion. They say, this is what the concept is, this is what this guy said, and this is how we understand Newton's equation, for example. And my point of engagement is, no, the children will have to ask, why should I ask that question? Why does that make sense to me? How will I come to that rather than start with that? And there, I think that kind of philosophical reflection is really the task of philosophy from my perspective. And maybe some philosophers may not accept this, but really, from my perspective, that is the way of thinking about it, making them question that and ask them, how could it be otherwise? What are the assumptions behind making this statement? And once you do that, I really believe that it enters into the children's way of thinking. But this is an extremely deep problem that you have alerted us to, and I really don't know, given the kind of antagonism towards philosophy in India today, and the kind of practices which some philosophy groups are doing, which is not helping the larger case, how to actually deal with this problem of education.
Okay, Professor Sundar, as of now, the speaker
Yeah.
panel is over.
Thank you.
Can
Yeah,
I
it
invite
is.
one more fellow? There is a personal request from a person. I
Okay.
want to ask something. Can I invite him? Yes.
Sure, sure. Yeah. Okay. Is the last question?
Last question,
Yeah.
probably.
Yeah.
Thank you so much.
Okay.
Ocean, you are invited. Okay, please ask your question. Please unmute and ask.
Okay. Can you guys hear me now?
Yeah. Yeah.
Okay. My question is about peer reviews and all these other kind of acceptance I have to get
Mm-hmm.
to come up with a out of the box idea. I find that in the present sense, if I have an out of the box idea like Earth is not the center of the universe or
Mm-hmm.
Earth is round, you think about those people. None of their peers agreed with them, and they put forward that idea. So, in this day and age, if I have an idea that is scientifically correct, but none of my peers agree to it, I cannot bet my paper on it. I'm just thrown in the waste bin. So,
Mm-hmm.
philosophically, maybe I'm correct. Scientifically, maybe I'm correct, but I need to have peer-reviewed papers. I need to have agreeable set of people. Do you think that is what the? I think that is the topic of this debate. So how to come out of it? Science is not about people agreeing with me, right? If I say something scientific and if I do not have anybody to agree with me, still it is science, right? Mic is yours.
Okay. Yeah. So, I think that's an interesting point. I think I will start with the last point. Actually, science is all about agreement. It's not about your articulation. If I look at it historically and as an institution, and that's why science is such a social entity, and that's the strength of science. The strength of science comes in the idea of justification, which is what defines scientific knowledge, in terms of acceptance by a peer community. So the fact that science moves from the very early pioneers of science, who were called amateurs, into professionals who are called scientists much later, it arises because there is a it has to be, any knowledge has to be legitimized by a community, never by the individual. In fact, it is such a truism for them. They believe in it so strongly that even today you cannot write a paper which just uses I as your person, individual. You cannot write. Even Einstein, when he's writing the E equal to mc squared, it will always be like, we can see that, we discover that, we can calculate that, etc. It's never that I got this great idea that E equal to mc squared. He cannot write that because it is part of the presentation of science that it is a collective, it is something which is collectively accepted and understood and not out of individual. So it will be very difficult for science to change this kind of a, because it is, I'll tell you why, there's a very deep philosophical reason for it. Science, in the right from its the definition of science, has to remove the human subject from science. That is, the human subject cannot be present in the world of science, because science is a collection of statements about the world independent of human beings' existence. So the earth goes around the sun independent of whether humans existed in this universe or not. And if that is the way in which you want to understand notions of scientific realism, then you have to completely eradicate the I and always present it as collective, or ideally independent of any human, any creatures. But if at all you have to use others, others are an integral part of it. So whether it's true or not is then left to the other people to decide. Even philosophy, by the way, all of our academic positions, just like as many ideas about science have been rejected. And remember, when I was telling you that 1 million papers are being produced, or 7,000 papers are being published every day, for those 7,000 papers which are published, you can imagine another 35,000 papers on an average will be rejected. That is the point. And all those 35,000 people sent their papers for publication thinking they have said something new. But only 7,000 per day are being printed. But 35,000 have been rejected, although the authors who sent them thought they were saying something new. So some people would find this very, I mean, as somebody who's interested in the nature of knowledge, I find this extremely odd and troubling that you spend so much time writing something and you reject 35,000 things and publish 7,000 per day. And another very big problem in that is all these are run by private publishing companies. It's another major racket. People who are not in science or academics are often surprised that, they often ask me, oh, you wrote this paper. I tell them something. They'll say, how much do you get paid for it? I said, I get paid for it. I mean, I don't get paid for writing something which you work on for 6 months or 1 year and some journal publishes it. Okay, typically I'm saying. And they are like, why would you then write all this and take so much time? You could have written something else and got paid for it. So the whole system of ecosystem is very different. And there are very important points you are raising, but I think science community is nowhere. There have been I must say also that there have been very innovative attempts to create archives, various ways of putting people's ideas in the hope that even if it is not published, somebody will discover it and so on. So some very creative ideas have been produced by science community, but the fact is sheer volume. Nobody can have the time to read the papers, go through them in full, spend time to learn it. So I think we are really looking at a major moment in time where we'll be rethinking what scientific knowledge is all going to be about.